Things around us aren't always what they seem. In the everyday world, we use a simple scale, ourselves, to know what's small and what's large. But what about the worlds that lie beyond? What is truly large and truly small? To explore, to observe, to understand the wider world we call the universe. This is one of the great human adventures. As we look out at the distant horizon, we may ask ourselves, what is our true place in the universe? We are all travelers on an unending voyage of discovery. More than 25 centuries ago, among the Greek islands, here at the vibrant crossroads of Africa, Asia, and Europe, philosophers began to devise rational theories about the world around them. The wondrous ways and forms of nature, they said, could be understood. One Greek thinker suggested that the Earth actually moved around the sun. Another taught that everything, the work of man and nature, was made of particles too small to see. Others estimated the sizes of the Earth and the Moon and the distances between them, and reasoned that both were spheres. But it would be many centuries before we had the tools to extend our vision and confirm the wisdom of these early thinkers. In the meantime, people around the world gazed on the stars and gave them names. Most assumed that the Earth was the center of an unchanging universe. "2,000 years passed before a revolutionary breakthrough was made by a mathematics professor in the ancient maritime republic of Venice. In 1609, Galileo Galilei demonstrated an instrument that would soon be called the telescope. From the tallest bell towers, he showed that this device could spot approaching ships hours before their sails were visible to the naked eye. Later, when he aimed his telescope at the night sky, Galileo discovered that the moon was a world with mountains. Jupiter had its own moons, and the Milky Way was a band of countless stars. Our own cosmic voyage begins here, in the center of Galileo's Venice, St. Mark's Square. Since the universe is a big place, we could easily get lost. So we'll need signposts to give us a sense of scale. The acrobat's ring is 1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. Now, with every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy. Six steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home in space. Eight steps on our outward journey, 8 powers of 10, and we pass the farthest reaches of human travel, the moon. If we visualize the paths that the 9 planets take in their orbits around the sun, at 13 steps from St. Mark's Square, the entire solar system comes into view. And with 15 steps, 15 powers of 10, we can see that our sun is just another star. From here on, our voyage will be measured in light years, the distance light travels in an entire year. Only now do we fly past our nearest neighbor stars, almost 5 light years away. The same journey at the speed of today's spacecraft would last 100,000 years. As we cross the perpetual night, our voyage takes us up and out of our sun's neighborhood, near the edge of a great pinwheel of stars. The Milky Way is actually a spiral galaxy, and our own sun is just one of 100 billion stars in it. At this immense scale, 23 powers of 10, each shining light we see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding. Our own galaxy, and all the others, form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know. While Galileo's telescope allowed us to take an outward voyage, another innovation, here in the Dutch town of Delft, would lead us on an inward journey of discovery. Over 3 centuries ago, Antony van Leeuwenhoek perfected the early microscope and used it to study droplets from the waterways of Holland. As students today make their own discoveries, imagine the moment when Van Leeuwenhoek peered through his more powerful instrument and discovered a living kingdom in a drop of water. This busy world of single-celled paramecia is only 1 millimeter across, 3 powers of 10 smaller than a meter. The microscope allows us to continue our journey into the realm of the very small. As we move into the cell nucleus, each new ring now reveals a world 10 times smaller in diameter than the last. Deep within the nucleus, we come upon truly remarkable constructions, long spiraling molecules of DNA. DNA holds the chemical codes for the reproduction of most organisms on the planet, whether they're paramecia, people, or petunias. Voyaging on, we see that molecules are made of even smaller parts called atoms. The tiny world of the carbon atom is very strange indeed. Its 6 electrons seem to swarm everywhere at once. Now our voyage takes us through a void that appears as vast as the space between the stars. Ahead lies the atomic nucleus, so fantastically small that if the whole atom were the size of this theater, its nucleus would be like a speck of dust. Yet the nucleus contains almost all of the atom's mass, packed into particles called protons and neutrons. And these, in turn, are made of still smaller, mysterious things called quarks. Exploring this, the inner frontier of the universe, physicists wonder if quarks might contain even tinier building blocks of matter. Scientists are investigating this mystery in an underground tunnel near Chicago, home of the giant Fermi-Lab particle accelerator, designed to create conditions like those that existed just after the birth of our universe. Millions of protons and antiprotons race through these pipes in opposite directions, nearly at the speed of light in a kind of subatomic demolition derby. Now, our cosmic voyage enters another dimension, the dimension of time, where knowledge is much less certain. Studying traces of quarks from these collisions, physicists try to learn what our universe was like when it began, after the explosion known as the Big Bang. One of them outlines the theory.
Welcome to Fermilab. Today, astronomers see the universe expanding. Imagine running the expansion backwards. Billions of years ago, everything must have been packed together at enormous density. It seems incredible, but we think that the matter making up everything we see in the universe today, everything, the buildings, trees, people, planets, stars out to the most distant galaxies, was once crammed together into a volume smaller than this. And then
space itself exploded in a burst of radiant energy. In those first dazzling moments, the newborn universe began to expand and cool. Quarks combined into protons and neutrons, which later attracted electrons to form atoms, and the vast fog lifted. For hundreds of millions of years, the force of gravity slowly drew matter together into a gigantic web, the architecture of the cosmos. Two billion years passed. Clouds of gas and dust condensed like giant water drops along the cosmic strands and formed galaxies. Where the great ridges of matter crossed, galaxies came together in clusters. Some galaxies evolved into gigantic disks and spirals of stars, gas, and dust. Neighboring galaxies, trapped by their mutual gravity, drove together in a fantastic collision. In real time, it would last 1 billion years. The force of gravity strips long tails of gas and stars from the huge new galaxy. And yet stars almost never collide. So vast are the distances between them. Perhaps 10 billion years pass, and we encounter our own galaxy, the Milky Way. In it, stars have formed, and some have died. Stars are nuclear furnaces. They shine until they use up their fuel. Massive stars end explosively. These exploding stars, or supernovas, send out the elements of life: the oxygen we breathe, the carbon in our muscles, the iron in our blood. Now a cloud of cosmic gas sprinkled with these elements comes together in the grip of gravity. A new star, our sun, ignites. Around it, planets form. In their infancy, over 4 billion years ago, our Earth and Moon were bombarded constantly by cosmic dust, asteroids, and comets. With violent impacts, volcanic gases, acid rain, and potent ultraviolet radiation from the sun, the young Earth was a very hostile world. And yet, the basic ingredients of life were already here. Water, carbon, and energy. Scientists speculate that molecules sheltered by the sea somehow combined, multiplied, and gave rise to life. For millions of years, Earth's only organisms were tiny bacteria. Some, called blue-green bacteria, slowly released tiny bubbles of oxygen and profoundly changed the atmosphere. Above the clouds, some of this oxygen formed a thin layer of ozone, blocking most of the sun's ultraviolet rays. In this changed environment, new organisms flourished in the Earth's waters. Colonies of green algae produced more oxygen. Then organisms evolved an astonishing variety of forms. Some with shells or skeletons for protection and support. Others evolved complex life cycles, like this tiny crustacean. And the shallow waters of the seas filled with a teeming diversity of life forms. Life's next challenge was to colonize the harsh, dry land. Bacteria were first, followed by algae, plants, and animals. Vertebrates appeared on land, feeding on both plants and animals, and gave rise to larger and larger life forms. Some of them conquered the realm of the air, and others the great open plains. Our cosmic voyage from the Big Bang to the appearance of humans took about 15 billion years. From the beginning, we were explorers, inventors, and technicians. And in a few thousand years, just an instant in cosmic time, curiosity and technology would take us back towards the stars. Since it was launched into orbit, the Hubble Space Telescope has captured images that reveal ever more beautiful and mysterious regions of the universe, where stars are dying out. And within the Eagle Nebula, strange towers of glowing gas are giving birth to new stars. In the Great Orion Nebula, disks of dust seem to be turning into solar systems just like our own. The grand adventure of cosmic exploration is accelerating rapidly, taking us into realms that once were the stuff of science fiction, like the mysterious black hole. Here, a red giant star is slowly being consumed, its gases swirling into the depths of a black hole. Some black holes may be collapsed cores of very massive stars, with gravity so powerful, not even light can escape them. But they can be detected when they attract and swallow nearby stars. For the first time in our history, we now have strong evidence that there are planets orbiting other stars. Scientists think there could be millions of Earth-like planets in our galaxy alone. If so, do any of them have life? Some radio telescopes search for signals that may reveal the presence of alien civilizations. It's a daunting task, but if one day we should receive a signal, it would forever change our view of ourselves and our universe. Telescopes, such as the giant Keck Observatory in Hawaii, are like time machines, capturing the faint light that has traveled towards us through all of cosmic history. The deeper astronomers look into space, the farther back they see in time. The more we learn about the universe, the more new mysteries we uncover. Profound questions for future generations of cosmic explorers. Will the universe go on expanding forever? Exactly how did life arise? Could there be other universes beyond our cosmic horizon? And are there others elsewhere in the universe asking the same things? Even to ask such questions is ambitious. But look how far we've traveled since our ancestors took the first steps in our cosmic voyage. Man must understand his universe in order to understand his destiny. Who knows what mysteries will be solved in our lifetime, and what new riddles will become the challenge of the new generations.